Hi everyone, this is Inorganic Tutor, which has been officially rebranded to Inorganic Tutors Institute. Wow, that is so amazing. And one exciting news is that we made our first 1K subscribers in the early week of April. And one good news is that we'll bring you full video on the reason for advancement of the channel from Inorganic Tutor to Inorganic Tutors Institute, and also we will give you full appreciation for engaging on our channel, for making us hit our first 1K subscribers in the early month of April. Congratulations to all of us. Now, in this lecture, we are going to cover coordinate geometry. So basically, in this lecture 1, we are going to cover 4 basic concepts in coordinate geometry, and that is going to be distance of a line between 2 points, midpoint of a line segment between 2 points, the equation of a line, and gradient of a line. So let's dive into it. Okay, so we begin with distance of a line between 2 points. Okay, so basically we know that distance of a line between 2 points, distance of a line between 2 points is given us, so let's say we are talking about point A and point B. Okay, so the distance of between this point A and point B is basically given as square root of x2 minus x1 all squared plus y2 minus y1 all squared, right? But how did we come about this formula? What is the process to the derivation of this formula? Basically, this formula is obtained through a triangle, right? The illustration of a triangle on two-dimensional plane. So let's draw our two-dimensional plane, right? So you have your y-axis, you have your x-axis here, right? So x here and your y-axis here. Now, we try to illustrate a triangle on this two-dimensional plane, right? So we choose any point, right? We choose any point. Let's say this is point 3, this is, let's say, 3, and this is, let's say, moving to this direction, and we join it to this point. So this is our triangle, right? So we call this part A, we call this part B, we call this vertex C. Okay, and this is a point, right? And every point has coordinates, right? So in of this point A, it has coordinate x1 and y1, right? And this point B has x2, y2, right? And that of C has x2, y1, right? Now, we want to find the distance between this line A and B. So, this is basically a triangle, right? And you know that a triangle, the longest side of the triangle is called the hypotenuse, right? The hypotenuse. So this is called the hypotenuse, right? And we don't know this side, we don't know the name of this side because we don't have anything showing that this is a right angle triangle. So we can't decide whether this is the opposite, or this is the adjacent, or whatever it is. But we know that the longest side is the hypotenuse, right? So once we know that the longest side is the hypotenuse, then we can say that the longest side, the square of the longest side, should be equal to the square of one side of the triangle plus the other side of the triangle, right? So let's say that this part is x2 minus x1, right? And this section is y2 minus y1 here. So that is the vertical section, and this is the horizontal section, right? So we have x2 minus x1 as line AC and line BC as y2 minus y1, and the hypotenuse is line AB, right? So now we want to find the distance. We know this distance and we know that of this, but we don't know that of this, right? So what we do is that we apply what we call the Pythagoras theorem. So with the help of the Pythagoras theorem, we can be able to derive this formula, right? So by the application of the Pythagoras theorem, we can be able to find the distance of line AB. So the distance of line AB will be equal to that over here, application of the Pythagoras theorem. Basically, we have to square this part, right? So that is equal to the square of line AC, right? So AC all squared plus that of BC squared. So we have plus BC squared. That is amazing. So we have all the coordinates, right? So now we can see that of line A and B, right, is going to be equal to, now we know we want this, right? So we take square root on both sides. So taking square root on both sides, this square will go off, and then you're going to have square root of line AC all squared plus BC all squared, right? So once we have this, we know that there is a coordinate for line AC, right? There is a coordinate for lines AC, and that is basically the difference between the difference between the A and the C, right? So that is basically going to be x2 minus x1 all squared plus that of this section, right? So that is y2 minus y1 all squared, right? So we have distance of line AB to be square root of x squared x2 minus x1 all squared plus y2 minus y1 all squared. So that is the process we go through to derive the distance formula between 2 points. So this is the distance formula between 2 points, right? So now let's take an example. Okay, so example one, we want to find the distance between point A and B given this coordinate. So find the distance between A of point 3 and 1 and that of B to be 5 and 2. Right, so this year we know that the first coordinate here represents, the first number here represents the x coordinates of A. So this represents the x coordinates, of A, and this represents the y coordinates, the y coordinates, the y coordinates of A. Here as well, this represents the x coordinates of B and that of y coordinates of B, right? So once you have been able to identify all these parameters, then the next thing to do is plug in those numbers and then simplify. So let's get into it. So here we know that our x2 is going to be 5, right? Our x1 is going to be 3, and our y2 is going to be 2, and y1 is going to be 1, right? So that is the basic thing we need to find the distance between these 2 points, right? So here we know that distance of line A and B will be equal to square root of s2 minus s1, so that's going to be 5 minus 3 all squared plus 2 minus 1 all squared, right? So here we simplify this and we're going to have 5 minus 3 is 2, 2 squared is basically 4, plus 2 minus 1 is 1, 1 squared is basically 1. So right here we're going to have square root of 4 plus 1, and that is 5. Okay, so the distance between line A and B is basically square root of 5 units, right? You know that distance can be meters, can be kilometers, can be centimeters, can be whatever. So in here, we don't know the actual unit. So the best unit we can put there is square root of 5 units. That's fantastic, right? So we have the process of obtaining the distance between 2 points. Let's take example 2. So example 2, want to find the distance, between B of points 1 and 2 and that of C to be 5 and 0. So we want to find the distance between points B of 1 and 2 and that of C of 5 and 0. So Z is basically going to be this. We know that our x1 is 1, our y1 is 2, and our s2 is 5, that of y2 is 0. So distance of line B and C is basically equal to s2, which is 5 minus x1, which is 1 all squared, plus 0 minus 2 all squared, right? So this is basically giving us 5 minus 1 is 4, 4 squared is 16, right? So 16 plus negative 2, right? Because 0 minus 2 is negative 2. Negative 2 squared is 4, right? So we have 4 here. And that is going to give us 16 plus 4 is square root of 20, right? So that is going to be square root of 20 units. So that is the distance between the line AB. So you can basically draw this line as something like this, B here and C here. And the distance between these two lines is uh, square root of 20 units, right? So that is the distance between these two lines. That is fantastic. So we have basically dive into the concept of distance between two points. So now let's continue with midpoint of a line, point of a line segment. Okay. So basically we know the formula, right? For the formula, everybody knows the formula, right? We know that if you want to find the midpoint of a particular line between 2 points, it's basically x2 plus x1 divided by 2 and y2 plus y1 divided by 2. So this is basically half of the x point, then half of y point, then you get the coordinate of the midpoint. That's it. So our interest here is to derive or go through the process to get this formula, right? So basically, this is just obtained from the illustration of two-dimensional plane, right? So let's say that this is, for instance, a line, right? So we say this is line AB, right? Okay. So if this is line AB and we want to find the midpoint of this, let's say this is the midpoint here. We want to find the midpoint. We don't know the actual midpoint. I want to find the midpoint of this line AB. Okay. Right. So this is a triangle and we form another triangle out of this here. Okay. Okay. So this is a beautiful triangle that we got from this. So that is line AB and we obtain a triangle on these lines, right? So let's assume that this is the midpoint, okay? This is the midpoint of this line AB. So let's say we are naming this part M, okay? And the coordinates here are basically X and Y. And we are assuming that this part is called Q, okay? And the coordinate of Q here is basically X2 and Y. And the coordinate of B is S2, Y2, and that of coordinate of A is X1, Y1. Okay? And let's assume that there is a point here, a point say P, and this P has coordinates say X and Y. Okay, so we have this information. We want to find the midpoint, right? So we say that the midpoint is the M, right? This is the midpoint here where these two triangles are intersecting, right? Okay, so we are interested in the midpoint of this figure, right? This line AB. Okay, so let's first find the first part of it, which is the S part, right? So we say that distance of A and P, which is A and P, right? So we are interested in the S coordinates, right? So the A and P will basically be equal to the A and P will basically be equal to distance of M, that is distance of M, right? And that of Q, distance of M, AP, distance of AP, right? distance of AP will be equal to distance of MQ. Okay, so that is basically true. Look at this here is basic. So from here, we can see that by change of subjects, we can have x minus x1 to be equal to x2 minus x here, right? By change of subject, we can have x minus x1 equals x2 minus x1. That is basically coming from here because we said AP, distance of AP should be equal to distance of MQ, right? So that is basically what we have. So change of subject, let's make x the subject. Okay, so making x the subject, we bring this x here, we're going to have x plus x to be equal to x2 plus x1, right? So we need the midpoint of this, right? So we're going to have x2 of the x to be equal to x2 plus x1, right? So we divide here by 2, divide here by 2, and that is basically equal to x to be equal to x2 plus x1 divided by 2. And that is how we do obtain the first coordinate of a midpoint, right? So x2 plus x1 over 2, that is basically obtained from here. Distance of A and P is equal to distance of M and Q. And that is basically true, this and this. Okay, now let's look at the y coordinate. So the y coordinate will basically be equal to distance of Q and M, right? So by the application of change of subject again, we will realize that y minus y1, of which we have it here, will be equal to y2 minus y, right? So by the application of change of subjects, we're going to have y plus y to be equal to y2 plus y1, right? So we have 2y to be equal to y2 plus y1. We have 2 here, we have 2 here. So we have y equals y2 plus y1 divided by 2. And that is the y coordinate. So this is basically the s coordinate and this is the y coordinate, right? So that is, we can say that that's the midpoint of a line segment is given as x2 plus x1 divided by 2, comma, y2 plus y1 divided by 2. So that is the formula for finding the midpoint of between 2 points, right? The midpoint between 2 points. Okay, so let's take an example to clarify this concept. So an example is, we want to find the example 1, we want to find the midpoint of A of, let's say, 3 and 1, and that of B, which is 0 and 1. right? We want the midpoint between these two lines, right? So the midpoint of the midpoint the midpoint of line A and B will basically be equal to, the formula as well, s2 plus s1 over 2, comma, y2 plus y1 over 2, right? So we have these informations. What we need to identify is the coordinates, right? So we know that x1 is equal to 3, x2 is equal to 0, y1 is equal to 1, and y2 is equal to 1, right? So we have this information, so we can say that s2 is basically 0 plus 3 divided by 2, comma, y2 plus y1 is basically 1 plus 1 divided by 2, right? So our midpoint is basically going to be 3 on 2 and 2 on 2. So this is going to yield 3 on 2 and 1, right? And this can be represented as 1.5 and 1. So they are all the same, right? So that is the process we go through to find the midpoint of a line between 2 points. Let's take example 2, okay? To enhance your understanding, okay? Always I want you to understand the concept, right? So example 2, we want to find the midpoint of, let's say, find the midpoint of B 3, 0 and C 5, 1. Okay, so in finding the midpoint of this between these 2 points, what we need first is to identify the coordinates, right? So the x coordinate here is our x1, the y coordinate here is the 0, the x coordinate here is the x2, which is 5, and 1 here is the y2 coordinate, right? Now we know all this information. So what we just need to do is to sum x2 and x1, sum y2 and y1, take average of each, and these 2 points become the midpoint of line AB. So we say that x2 plus x1 divided by 2, comma, y2 plus y1 divided by 2 will be the midpoint of line BC. So we're going to have 5 plus 3 on 2, comma, 1 plus 0 on 2, right? And that is basically 8 on 2 and 1 on 2, right? So we're going to have 4 and half. So that is the midpoint of line B of 3 and 0 and C of 5 and 1. So that is basically the process we go through to find the midpoint between a line. Okay, so we continue with gradient of a line. Okay, now basically we know that gradient of a line has its formula to be y2 minus y1 over x2 minus x1, right? That is what we are aware of, right? That is gradient of a line. How did this formula came about? Okay, so basically we are going to use this same illustration from the XY plane, obtaining the triangle on it. But this time around, we're going to make it a right angle triangle, because gradient of a line can also be obtained in terms of an angle, right? So basically, let's illustrate our X and Y plane, right? So we have our triangle in here. We have our triangle in here. Okay, so we say this is A, this is B, and this is C, right? And this time round, we are going to name this part theta, right? And we position our right angle, the 90 degrees there, showing that this figure is a right angle triangle. Now, we know that this distance, let's say this distance is x2 minus x1 here, and that of this is y2 minus y1, right? So basically, we know that the distance of line AB is basically the square root of this squared plus this squared, right? Now, the gradient is basically giving us the gradient of line AB is giving us y2 minus y1 over x2 minus x1. That is basically from here, right? Now, because this figure is a right angle triangle, then we can say that, or because we have a right angle triangle, by using the trigonometric identities, then we can say that the gradient of line AB can be given in terms of an angle, right? So we can also write the gradient of line AB as tan theta, So we can also say that the gradient of AB, right, will be equal to tan theta, right? That is basically from here. We know that tan is basically twa, right? From the SOHCAHTOA something, you know that from trig SOHCAHTOA, right? Right. So we know that tan is opposite over adjacent, right? And we have it here, right? So we know that line AB will basically be tan theta. So opposite of which we have here, and then the adjacent is here as S2 minus S1. So in terms of angle, we can say that line AB, the gradient of line AB will be equal to tan theta. So basically, gradients can be obtained in terms of angle, and it can be obtained in terms of real numbers as well. So let me simplify it. So in all, we see that the gradient of line AB is giving us y2 minus y1, and that is over s2 minus s1. And because of trigonometric identity, particularly focusing on the right angle triangle, this can be obtained as tan theta. So these are the formulas for the gradient of a line between 2 points. Now, we continue with equation of a line before we solve an example, okay? So equation of a line here from this same triangle, right? If you want to find the equation of a line from 2 points, right, is basically this, this is the gradient, right? So let's, for instance, say that M represent the gradient, right? So let's say this is basically equal to M, right? So if you want to find the equation of this line AB, then it's basically going to be, we cross this here, right? So it's going to be M of S2 minus X1, right, equals Y2 minus Y1, right? So we position it well, and we're going to have Y2 minus Y1 equals M into X2 minus X1. But the truth is, this part, right, this part, we are not going to use y2 minus y1. It's basically going to be y minus y1 equals m into x minus x1. Okay, because we want an equation. We don't want to, we don't just need a real number, right? So this time round is going to be y minus y1 equals m into x minus x1. So that is basically an equation of a line. So equation of a line is obtained from the formula of the gradient of a line. So, but in the equation of a line, we basically want to find the equation of a particular line. So we want in terms of variables. So right, we want it in terms of the x and y. So that is why is basically y minus y1. y1 is the known point, as well m will be known, which is the gradient. X1 is also known, but x and y are not known, and that makes it an equation of a line. So that is basically the formula and the derivation of the formula. So now let's take example of gradient, how to find a gradient and how to find equation of a line. So let's consider this example here. So example one, want to find the distance. Okay, no, this, we are done with the distance, right? You want to find the gradient and equation of the line A of 3 and 1, and that of B to be 5 and 0. Okay, so we want to find the gradient and as well the equation of that particular line A, B. So right here, we know that from these 2 points given, we can obtain our x1, our y1, and we can obtain our s2, y2, right? So our x1 is 3, our y1 is 1, our x2 is 5, and our y2 is also 0. So to find the gradient is basically equal to, gradient of line AB will be basically equal to y2 minus y1 over x2 minus x1, right? And y2 is 0 and y1 is also 1, right? Over x2, which is 5, minus x1, 3, right? So we have our gradient to be negative 1 over 2, right? So we have our gradient to be negative half, right? So this is the gradient of line AB, right? So once we have the gradient, we want to find the equation of this line, right? So equation of a line AB, equation of line AB will be basically equal to y minus y1 equals m into x minus x1, right? So here we know our m to be negative half, and here what we do is that we decide on either of the points. So one person can choose point A together with the gradient to find the equation of this line, and other person to can choose the point B together with the gradient to find the equation of this line. And these two individuals must result the same equation of a line. You must have the same equation of a line, right? So here I'm considering the point A first. So let's consider point A, right? 3 and 1, right? So here our x1 is 3, our y1 is 1, and we know our gradient to be negative half, right? So once we know this information, we just substitute to find the equation of the line. So we have y minus y1, which is 1, equals our gradient, which is minus half, into x minus x1, which is 3 here. So we're basically going to have y. So this is negative half, right? So we can spread the 2 across board to avoid this fraction here. So we're going to have 2 into y minus 1 equals negative half, negative 1 into x minus 3 here. So this is basically going to be 2y minus 2 equals negative x plus 3, right? So making the change of subjects, right, we're going to have 2y plus x equals 3 plus 2, right? So we're going to have x plus 2y equals 5. And that is the equation of the line AB, right? Note, I considered point A together with the gradient, and I had x plus 2y equals 5. In other words, I can also use the point B, and I must get the same solution, the same equation of a line. So let me consider point B and the gradient as well to see the confirmation. So here I'm going to use the point B, which is here, and our x1 is 5, our y1 is 0, right? And as well, our gradient is minus half, right? So once we have these informations, then what we do is that we substitute into the equation of a line formula here, and we have this. So y minus y1, which is 0, equals minus half into x minus x1, which is 5, right? So we spread these two across board, and we're going to have 2 into y minus 0 equals negative 1 into x minus 5, right? So we spread this here, 2y minus 0 equals negative x plus 5. That is interesting. So we bring this x here, we're going to have 2y plus x equals 5. You can see that we are getting x plus 2y equals 5 as well. So either point you choose together with the gradient, you must have the same equation of a line. Now, it's interesting, right? We have been able to cover these 4 concepts in one lecture. Distance of a line between 2 points, gradient of a line, equation of a line, and the midpoint of a line segment between 2 points. So basically, that is the end of this lecture, and I want to add up this short note here. So note, if L1 and L2 have gradients M1 and M2, and they are parallel, to each other, then we can say that these two lines have equal gradients. So that's M1 will be equal to M2. So note this very well. Two. If L1 and L2 are perpendicular, okay, and they have gradients M1 and M2, then we say that the product of their gradients, that is M1 times M2, will be equal to -1. So note this very well. This is basically an objective information. So if L1 and L2, L1 and L2 are basically lines, right? And if they are perpendicular and they have gradients M1 and M2, then we can say that M1 times M2 should be equal to -1. So basically, in other words, we can say that M2 is equal to the negative reciprocal of M1. So note this very well. They are objective informations. So notice if they are perpendicular, then the product of the gradient 1 and gradient 2 will be equal to -1. And in other words, M2 is equal to negative reciprocal of M1. And if they are parallel, then line 1 and line 2 having gradients M1 and M2 have M1 equals M2. And that is the end of lecture 1. Thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mates, like, and comment as you watch. Bye-bye.